Hello, my name is Michael Spiegel, and I'm the President and Chief Operating Officer for Brooks Rehabilitation. Increasingly, technology is playing a greater and greater role in rehabilitation. Before selecting advanced technology, our physicians, therapists, and clinicians spend a great deal of time evaluating the technology to ensure it can have an immediate impact for patients. This brought us to Cyberdyne, a technology company based in Japan. We are excited to be partnering with Cyberdyne to introduce the Hybrid Assistive Limb, or HAL technology, to the United States as a treatment for patients following a spinal cord injury, along with performing research aimed at expanding the use of HAL for patients recovering from other neurological injuries or illnesses.
I'm Hiro Kimura, and I'll be demonstrating the motion principle for the Hybrid Assistive Limb made by Cyberdyne Inc. in Japan. When a person attempts to move, the brain sends a command signal down their spinal cord, through the motor nerves, and to the muscles. When these signals reach the muscles, small, faint bioelectrical signals can be detected on the surface of the skin. For a patient with a spinal cord injury, the signal from the brain to the muscle gets interrupted. Even with very, very faint signals at the surface of the skin, the robot can detect them and complete the movement. To demonstrate how this works, I'm going to actually control the robot without actually moving my right leg. So I'm going to lift my leg up, bend the knee, extend, bend, extend, bend, extend, and relax. The robot can pick up these faint signals for spinal cord injury patients and help them complete their walking movements.
My name is Bob McIver. I'm a physical therapist at Brooks Rehabilitation. I also act as our Director of Clinical Technology. We're really excited about this new opportunity with our partnership with Cyberdyne and the use of its HAL robotics. There's no other place in the United States that patients have access to this technology. HAL can be confused with typical exoskeletons simply just based off of its design. But the way that HAL is structured to work is as an advanced robotic technology, meaning that it's not there to support you and help you stand up and move. It's to help you produce voluntary, meaningful movements. We had a patient of ours that had never seen HAL before. He is a C5 quad, and so being that his injury is 5 years old, it's chronic, the likelihood of having any spontaneous recovery is very, very minimal. At the beginning of the session, put him in parallel bars, and he had a hard time coming from a sit to stand and walking throughout the bars once or twice. After fitting him with the HAL device, we progressed him walking through various assisted devices in a total of 40 minutes. By the end of that session, he was walking with a much better stride length, a much better coordination, and much better balance just by using HAL. We took the HAL robot off of Chris and we put him back in the parallel bars. You could see that he was able to step, he was able to move, and able to perform simple sit-to-stand transitions much easier than he could at the beginning of the session. It is pretty substantial that somebody can progress with their balance and with their mechanics that quickly. We're very excited about the potential for recovery that we can help promote through our center here. Our hope is to continue working with Cyberdyne to produce more and more advanced technologies to help patients return to a more independent function.